In this video, we are going to talk about factoring. So first, how do we factor? Number one, we can factor out common factors. Number two, we can use special factoring formulas like a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, and a cubed plus b cubed is equal to a plus b times a cubed minus ab plus b squared. Number three, factoring completely. Number four, can group terms together. Number five, adding and subtracting perfect squares. So here are sample problems. Number one, x times a quantity x minus 1 minus y times a quantity y minus 1. So to solve this, let us first distribute the outer variables. So we will get x squared minus x minus y squared plus y. From this, we can group terms together to simplify this. As you can see, we can group x squared minus y squared, which is a special product for the difference of two squares. So doing this, we get x squared minus y squared. Then we group together the x and the y, factoring out the negative, minus x minus the quantity x minus y. Then we expand the quantity x squared minus y squared, which is just equal to x plus y times x minus y. We copy minus the quantity x minus y. From this, we can see that we can factor out x minus y from the two terms. So the resulting answer would be x plus y minus 1 times x minus y, which is also the final answer. For problem number 2, we have 2ab plus bd minus 2ac minus cd. So looking at the problem, we can see at first we don't know which terms to group, but after further analysis, we can see that if we group the first two terms and the last two terms, we can simplify the problem. So grouping the first two terms, let us eliminate the common factors. Let's bring out the common factors. So the common factor is b. So the resulting equation would be b multiplied by 2a plus d. Then for the last two terms, the common factor is negative c. So we take negative c out, so it will be negative c times 2a plus d. So the two terms both have 2a plus d in them. So we can factor it out, 2a plus d out, and the answer would be b minus c times 2a plus d, which is also the final answer. The third problem is a more challenging one. X squared plus 4. At first glance, it may seem that this is already the factored form, but we can further simplify this. Remember the fifth way of factoring, adding and subtracting perfect square. So what do you think should we add or subtract to get a perfect square trinomial? We can see that the first term x squared is actually x squared squared, and the second term 4 is actually 2 squared. So we could find the perfect square trinomial for this if we have the proper middle term. So what should the middle term be? Remember that the middle term is 2 times the first term and the last term. So the middle term is actually should be 4x squared. So what we do is we add 4x squared to the equation, but we subtract it again in order to maintain the equality. So we come up with the resulting equation: x squared squared plus 4x squared plus 2 squared minus 4x squared. Then the first three term is actually a perfect square trinomial, so we can simplify it as x squared plus 2 quantity squared minus 4x squared. Noticing that this equation is actually a difference of two squares. We can further factor it out, and we get the final answer, which is x squared plus 2 plus 2x times the quantity x squared plus 2 minus 2x. For our fourth problem, it is actually kind of similar to the third one. X fourth plus 4x squared y squared plus 16y squared. So again, what should the middle term be in order for this to be a perfect square trinomial? As I have said, the middle term should be 2 times the first term and the last term. So our first term is x squared and the last term is 4y squared. So the middle term must be 8x squared y squared. But we only have 4x squared y squared. So what do? We add perfect square. We add 4x squared y squared again. So if we add 4x squared y squared, we get the resulting equation. So x squared plus 4x squared y squared plus 4x squared y squared plus 4y squared quantity squared. Then we subtract what we added, which is 4x squared y squared. Again, the first 3 terms is actually a perfect square trinomial, so we can simplify it into x squared plus 4y squared quantity squared. And the last term, we copy it, it is minus 4x squared y squared. Again, this is a difference of 2 squares, so we can expand this to the final answer, which is x squared plus 4y squared plus 2xy multiplied by the quantity of x squared plus 4y squared minus 2xy. The fifth and the last example is this: 1 minus a squared plus 4ax minus x squared plus a squared x squared. So at first you will find it difficult to pair the terms, but once you see that a squared, there is an a squared and x squared, and there is a term with ax, so it must be you can form a perfect square trinomial with that. So you group them together, so you get the other term out, 1 plus a squared x squared, then you factor out the negative sign, minus the quantity of a squared minus 4ax plus x squared. Then look at the last 3 terms. You can form a perfect square trinomial with that. But what should the middle term be? Again, the middle term should be 2 times the first term and the second term. So the middle term must be 2ax, but we have here negative 4ax. So what do we do to get 2ax? We can actually add 2ax in order to make the middle term minus 2ax, which is also a perfect square trinomial, like this: a squared plus 2ax minus 4ax plus x squared. Then we subtract what we added, which is 2ax, and copy the rest. Then we get this: 1 plus a squared x squared minus a squared minus the quantity of a squared minus 2ax plus x squared minus 2ax. A squared minus 2ax plus x squared is actually a minus x quantity squared. So we can remove the grouping signs, and this is what we will have: a squared x squared. We move the positive 2ax to the front, plus 2ax plus 1 minus the quantity of a minus x quantity squared. So the first 3 terms are also form perfect square trinomials. So it's the first 3 terms form ax plus 1 squared. This term, ax plus 1 squared minus a minus x quantity squared. So this is again a difference of 2 squares, and we can expand it, which is just equal to ax plus 1 plus a minus x times ax plus 1 minus the quantity of a minus x. Simplifying this, we get the answer: the quantity of a minus 1 x plus a plus 1 times the quantity of a plus 1 x minus a plus 1.